I'm going to go over protecting groups for alcohols. So the hydroxyls of alcohols, they are poor leaving groups for nucleophilic substitution reactions. So for nucleophilic substitution reactions, you usually need a good leaving group in order to kick it off, but hydroxyls aren't great leaving groups. So what we usually do is they can be protonated and reacted in order to form better leaving groups, and those leaving groups are called methylates and Tosylates. So in this reaction, the alcohol acts as a nucleophile and it's converted into an ester, a type of ester called sulfonate. And sulfonate ions are weak bases, so they make excellent leaving groups, and that helps when you're doing a nucleophilic substitution reaction. But they can also be used as protecting groups for alcohols against oxidizing agents. So if you convert an alcohol into a methylate or a tosylate, you won't, if you use an oxidizing agent like BCC or anything against it, it won't be able to oxidize it. So first thing, methylates, so they contain the functional group SO3CH3. So instead of OH, you replace it with an SO3CH3. And this is prepared using methyl sulfonyl chloride and an alcohol in the presence of a base. You don't need to know the really the specific reaction or how it works, but just know what happens when you convert into methylate and kind of what the general reaction looks like. So when you convert to a methylate, it becomes a good leaving group in a nucleophilic substitution reaction, but also you can use that as a protecting group against oxidizing agents. Tosylates are similar, except it has a different structure. It has the formula of SOC6H4CH3. And similarly, you react an alcohol with p-toluene sulfonyl chloride in order to form an ester called toluene sulfonic acid. So both methylates and tosylates, they're called sulfonate ions, and they're used as protecting groups for alcohols. And then similar kind of alcohols can be used as protecting groups for other functional groups like aldehydes and ketones. And this is to prevent reduction by reducing groups. So when you react an aldehyde with two equivalents of alcohol or a diol, so a molecule with two alcohol groups on it, you form an acetal. These are primary alcohols with two OR groups and a hydrogen group attached to it. So this would not be able to be reduced by a reducing group or a reducing agent. So this is to protect the aldehyde from being reduced back into an alcohol. And similarly, if ketones are reacted with two equivalents of an alcohol or a diol, it forms ketols. This is a secondary alcohol with two OR groups attached to it. And similarly, it's used to prevent reduction by reducing groups. And if you want to get rid of the protecting group, or otherwise known as deprotection, in order to convert it back to a carbonyl, you react the molecule with aqueous acid in order to kick off the alcohol or a diol in order to get your ketone or aldehyde back. And this is just just to show how that reaction works. So you can see there's a carbonyl on the ring, and when you react it with this diol, it forms this pentagon-looking group, and that protects the ketone from being reduced. And when you react it with acid, it converts it back to a carbonyl group.